Welcome back to the channel where we turn fun and practical Python projects into simple lessons you can actually follow. Today's project is a classic arcade game, Snake, but with a twist. We'll build a colorful, modern version with a game over screen, a restart button, and a quit button, all using Python's Tkinter library. In this video, I'll walk you through the full build in some minutes, from the moving snake to collision detection and replay functionality. If you're new here, don't forget to like the video, subscribe, and hit the bell icon so you never miss beginner-friendly Python tutorials. Let's break it all down step by step. Step number 1, Imports and Constants. We start by importing Tkinter for the window and graphics, and random for placing the food. Then we set constants. Move_increment is how far the snake moves each step, and game_speed is how fast the game updates. Step No. 2, Setting game speed in pixels. Here we're defining two constants that control the game's speed and movement. Move increment is set to 20. That means every time the snake moves, it will jump 20 pixels forward, matching the size of each grid square on the board. Game speed is set to 100, which is the time delay between each movement in milliseconds, so here, the snake updates 10 times every second. If you want a faster snake, lower this number. If you want it slower, increase it. Step number 3, Game Initialization. Now, we're creating a class called SnakeGame. This is where we'll store all the game's code in one place so it stays neat and organized. Inside it, we have the init method. This is called the constructor, and it runs automatically when the game starts. First, we store the main Tkinter window in self-root so we can use it later. Then we set the window's title to Colorful Snake Game with a fun emoji. Next, we create our game canvas. This is like a drawing board where everything happens. It has a dark background, is 400 by 400 pixels, and we use pack to display it on the screen. We also make two placeholders, self-restart button and self-quit button. These will be used later when the game ends, but for now, they're set to none. We call self-initialize game to set up the snake, the food, the score, and all the starting values. Then we bind the arrow keys to our change direction method so the player can steer the snake. Finally, we call self-run game to start the game loop. This is what keeps the snake moving and updating until the game ends. Step number 4, Setting the starting game state. Next, we have the initialize game method. This is where we set all the starting conditions for the game. First, we set the score to 0, because every new game starts fresh. Then we create the snake's starting body, 3 blocks in a row, positioned horizontally at coordinates 100, 80, and 60 pixels on the x-axis. We place the first piece of food on the board by calling self-place food. We set the starting direction to right, so the snake begins moving automatically when the game starts. And finally, we set self-running to true, which tells the game loop that the game is active and should keep running until a collision happens. Step number 5, Drawing the snake, food, and score. Now we have the draw method. This is what updates the visuals on the screen every frame. First, we clear the entire canvas using delete all so we can redraw everything fresh and avoid leaving old shapes behind. Next, we display the score at the top of the screen, in white text, using a bold Arial font so it's easy to read. Then we draw the snake. We've prepared a list of gradient colors, shades of green and yellow to make the snake more vibrant. We loop through each segment of the snake's body, choose a color based on its position, and draw it as a rectangle with a dark outline. Finally, we draw the food. We take the food's X and Y position and draw a small oval in bright pink, with a soft pink outline, to make it stand out on the dark background. This method runs over and over to keep the snake and food updated on the screen. Step number 6, Moving the snake and checking for collisions. The move method is the heart of the game. This is where we update the snake's position and check for collisions. First, we take the current head position of the snake, which is always stored at index 0 of the self-snake list. Then, based on the current direction, we adjust the head's X or Y coordinate. Moving right increases X, moving left decreases X, moving up decreases Y, and moving down increases Y. The amount we move each time is exactly our move_increment value. We then store this as the new head position in a variable called newHead. Next, we check for collisions. If the new head position is already part of the snake's body, that means we've bitten ourselves. Or if the X or Y position goes outside the 400 x 400 game area, that means we've hit the wall. In either case, we set self-running to false, call the game over screen method, and stop this move. If we didn't crash, we insert the new head position at the start of the snake's body list, making the snake appear to move forward. Then, if the new head position is exactly where the food is, we increase the score by 10 points and place a new piece of food randomly on the board. In this case, we don't remove the tail, so the snake grows longer. Otherwise, if we didn't eat food, we remove the last segment of the snake's body so its length stays the same. This method runs every game tick to keep the snake moving and reacting to the player's input. Step number 7. Placing food at a random position. The place food method is responsible for putting food on the board at a random location. We use a while true loop so the code keeps running until we find a valid spot. First, we pick a random x and y position using random rand_int. Since each snake segment and food item is 20 pixels in size, multiplying by move_increment makes sure the food lines up perfectly with the game's grid. Then we check, is this new position already part of the snake's body? If it's not, we return it as the food's location. If it is, the loop continues until we find an empty spot. This way, food never appears inside the snake. Step number 8. Handling direction changes. The change direction method controls how the snake changes direction when the player presses an arrow key. It takes the key that was pressed and stores it in a variable called key. We create a dictionary called opposite that lists the opposite directions, for example, up is opposite to down, and left is opposite to right. Next, we check if the key pressed is one of the 4 arrow keys. If it is, we also check that the new direction is not the opposite of the current direction. This prevents the snake from turning directly back into itself. If both checks pass, we update the snake's direction to the new key. Step number 9. Displaying the game over screen. The game over screen method is called when the player loses. First, it clears the canvas so nothing from the game is left on the screen. Then, it writes a large red message in the middle that says, Game Over. Below that, it shows the player's final score in white text. Next, it creates 2 buttons. The first is a green, Restart, button with a circular arrow icon. When clicked, it calls the Restart game method to start a new match. The second is a red, Quit, button with a cross icon. When clicked, it closes the game window. Both buttons are placed under the text so the player can choose whether to play again or exit the game. Step number 10. Restarting the game. The restart game method resets the game so the player can start again without closing the window. First, it checks if the restart button exists, and if it does, it removes it from the screen. It does the same for the quit button. Then it calls initialize game to reset the score, the snake's position, the food, and other starting values. It calls draw once to show the fresh game board. Finally, it calls run game to restart the main game loop and get the snake moving again. Step No. 11. The run game method is the main loop that keeps the game running. It first checks if the game is still active by looking at self-running. If it is, it calls move to update the snake's position and handle any collisions. Then it checks again. If the snake is still alive after moving, it calls draw to update the visuals on the screen. Finally, it uses root after with the game speed value to schedule the next run of this method, creating a repeating loop until the game ends. Step number 12. At the very bottom of the script, we have a standard Python check, if name main. This means the game will only run if this file is executed directly, and not if it's imported into another file. Inside this block, we create the main Tkinter window and store it in root. We then create an instance of our snake game class, passing in that window so the game can draw on it. Finally, we call root main loop to start Tkinter's event loop, which keeps the window open and responsive until the player closes it. And there you have it, your very own colorful snake game with a game over screen, restart, and quit buttons, all built in Python with Tkinter. You've learned how to set up the game window, draw the snake and food, handle movement, detect collisions, and manage game flow with a loop. You also added interactive buttons to restart or exit without closing the program, just like in a real game. If you enjoyed building this project, hit that like button, subscribe to the channel, and turn on notifications so you don't miss the next tutorial. And I'd love to see your version. Maybe you change the colors, add sound effects, or make the board bigger. Share your creations in the comments. Thanks for watching, keep coding, and I'll see you in the next project.